In this episode, we talk about the engine powering Simple's data analytics in Amazon Web Services. Hey everyone, and welcome to Scala Code. I'm glad you're joining us for another episode, which I think you'll find very insightful because we're covering what I think are interesting and useful topics, and I've got an interesting guest joining us today to share his experiences. Jeff Klukas has what I think is a particularly intriguing background, and I let him tell you all about it because first, I need to thank two amazing sponsors, DigitalOcean and Linux Academy. If you have any ideas or if you just want to practice your skills in the cloud, I highly recommend that you try DigitalOcean, and I've got a special discount for you at scalayourcode.com/DigitalOcean. You'll get a free month on a 1 gigabyte droplet, which you can spin up in 55 seconds. They also offer one-click apps, like for lamp stacks or anything popular like that you can quickly and easily install. So check that out. Next, if you also want to take your skills to the next level for Linux Academy, Amazon Web Services, DevOps, and OpenStack, go to scalayourcode.com/Linux Academy. You've probably already heard me talk about these two, so make sure to check them out. Now, Jeff, thank you so much for being here and for joining me today.
Thanks for having me.
So I said you have an intriguing background in the introduction of this episode, and you were a research assistant for the University of Wisconsin-Madison. Can you tell us a little bit about what you did there?
Sure. I ended up in grad school. Actually, I was intending to teach physics at the undergraduate level as a profession, but got to grad school, ended up working in experimental particle physics on the Large Hadron Collider, which shows up in the news every once in a while. So the LHC is the largest particle accelerator in the world. Right now, it finally found the Higgs boson, which is this thing that we've been searching for 40 years. And there was a Nobel Prize that came out of that for the theorists that originally came up with the idea. So it was an inspiring project to work on, just because of the scale and really being at a frontier of physics. So I mean this collaboration is thousands of physicists. You end up playing a very small part in that. But kind of what that research life was like was doing a lot of computing. Really, that particle physics has been kind of a pushing the boundaries of what we can do with distributed computing for decades. And so what ended up what life was like was I would often write some C++ code, kind of test it out locally on some data, then send it to a global grid. Some jobs would run overnight. Some of them would run on our local cluster at Wisconsin. Some of them would run in Taiwan. Some of them would run at CERN in Switzerland, where the actual experiment was. You'd come back and analyze the results the next day. So it was really awesome to be a part of an infrastructure that was that big, and I ended up falling in love with programming as part of that, and that's kind of how I ended up getting into the kind of position that I'm in today, where I'm doing data engineering, I'm doing software development, and that really came out of as I was doing research, I found that I was doing a lot of kind of automating workflows for people, and seeing analysis tasks that we just did over and over again. Every time, and I became very interested in how do we structure this? How do we build tooling so that the people that I'm working with can be as efficient as they can be, and that's been a theme that's kind of kept on going throughout my career.
I'm sure that was a very inspiring experience. And is that really where the connection came from? Because now you're at Simple, which is a banking platform. So did you take that experience of automation and finding relationships with data and you brought it to Simple? Is that where the connection really is there?
Yeah, I think that there are some kind of direct connections in terms of technology, thinking about distributed systems, and I work with a lot of distributed systems now. But I think a lot of it is just the mindset that you get from doing analysis work in a science like physics, where you're doing analysis, you get results that don't make sense. You have to go back, kind of trace through the pipeline of, okay, what did we do? Why, is this something actually interesting? Is it some artifact of, the way that we've gone about doing the analysis? So there are a lot of parallels between that whole process and what you do to find, bugs in code and to, restructure it and make it perform well. So yeah, definitely the kind of questions and the kind of mindset that you develop by doing that sort of analysis has been, very transferable to thinking about technology and dealing with the kinds of problems that we're dealing with. It's simple trying to do data analysis and building an infrastructure to make that efficient.
So I said that Simple is a banking platform. Can you give us a little bit more insight into what it really offers?
Sure. Yeah, so Simple does work in the realm of consumer banking, and we kind of offer what you might expect from a bank in terms of we offer a full-fledged checking account. But we're very much a technology company, and what makes us different is that we're trying to build banking for the way people think rather than the way that banks work. And to give you a little bit more context of that, we have have this checking account, but we have apps where we have savings and budgeting tools built right in and very tightly integrated with your account. And that lets us really change the relationship that people have with their money. One of the best examples of that is that when you first sign up for Simple and log into the app, the number that's presented to you front and center isn't your traditional bank account balance. It's what we call safe to spend. So it's that account balance, but it also takes into account what pending transactions do you have, what bill payments do you have coming up that you've scheduled, and what goals have you set in the app. We have this whole system for you can set a goal and it'll slowly take money out of your safe to spend and sock it away somewhere so that you are going to have spending habits that are consistent with where you want to be, and that number that you see is what can I spend today without causing an impact to my goals or these bills that I need to pay coming up.
So is that the kind of data that you're working with, where you're crunching those numbers and trying to figure out what the safe to spend amount is and fraudulent activity and things like that, or are you working on a different set of data?
So yeah, so it's interesting. Our team sometimes gets involved with those product questions and helping to understand when we have a data problem like that. But that's not the main focus of our team. Our team is really focused on analytics, getting a wider view of what's going on with the business rather than driving the product itself or writing the code that makes the app work and that gives you something to talk to when you're on your phone. So when I talk about analytics, it's about a lot of what we've been focused on is creating a data warehouse, which we use Amazon Redshift for, and it's about getting data from all different parts of the business. We have a lot of backend, databases that are powering all of that user activity. We want to integrate all of that information into one database and also have things like events from our web apps, from our marketing site, having all of that in one place so that we can do analyses that are across that historical time series without having to hit all of those production databases and architecture.
So you've built a sort of funnel that receives data from different kinds of sources, and then you sort it out and use Redshift to make sense of that data and maybe find some relationships between different sets of data and things like that. Can you walk us through a little bit more of how that's set up? You mentioned Redshift. How does Redshift receive data? Where does the data come from? That sort of thing?
Sure. So our architecture is the data architecture that we've set up is largely mirroring what already existed in our backend architecture. So when I say backend architecture, I'm talking about all the services that power the banking side of what we do and power the apps. Those are the things that you're interacting with directly when you're using the web app or one of our mobile apps. So so that was built as as microservices that are mostly written in Scala. We adopted those same patterns, so we've ended up building a variety of services to pull in data and then to load that data into Redshift. So the primary thing is the first thing that we built was a service to do that loading of data into Redshift. So it reads information in on a message queue, in our case RabbitMQ. It batches that data up, puts it to S3, which is really the way that you get information into Redshift. That's how Amazon has set up the most efficient pipeline. So it batches up data to S3, and then it has logic to actually do the copy commands to Redshift to take that data from S3 and get it into Redshift itself. And then the rest of our data architecture is about funneling data into that loader service. So we have a variety of different services. One reads from various backend RabbitMQ exchanges and transforms those messages, puts them onto the queue that our loader service eventually reads. We have one that does queries against backend databases to pull in new records, and again transforms those and then puts them on a message queue for our loader to take in. And then we have one that accepts client analytics, so all of those events of users clicking on our marketing site or in our web app or in the mobile apps ends up hitting an HTTP service that then sends things off on a message queue to be loaded into Redshift.
So you have both internal and external facing APIs that receive data from different services. Like I know you're using Postgres, for example, so you might get some data from that, and then you've got data coming from or going to clients. So I'm assuming you have to authenticate them somehow and route them to the right queues, etc. And then after that, it goes to the loader, which then batches it up and goes to to Amazon S3, which then loads it into Redshift, right? Is that right?
That is correct. Yep.
Did you build the loader itself? Is that custom built, or is that something that you found, or how does that work?
Yeah, the loader is custom built, and this is one of the kind of heartbreaking things about working in a world where technology is just constantly changing. If we were starting building the same architecture from scratch today, Amazon offers a lot pre-built that didn't exist a year and a half ago when we were first building this. So Amazon now provides they have Kinesis Firehose, which that's just you put messages onto Kinesis and then it handles all of the logic of batching to S3 and loading it into Redshift for you. And that's kind of behind the scenes using Lambda and Kinesis, their message queue system. So and we're working to try to leverage some of that that Amazon provides now, so that we have less infrastructure to maintain ourselves, and we're hoping to eventually get to a point where we use the Lambda loader part of that that Amazon offers to actually do the once things are batched into S3, Amazon provides a Lambda function that can do the copying of that data into Redshift for you, and that'll mean a whole service that we can take out of our infrastructure and leverage something that Amazon provides for us.
They also offer, for example, SQS as a queuing service. So is that did you end up going with RabbitMQ instead because SQS wasn't there at the time, or is there a specific reason that you chose RabbitMQ because it offers something that you can't find in other queuing services?
Yeah, that is a really interesting question, and that's something where history again becomes very important. Of that decision. RabbitMQ has been a part of our backend infrastructure for many years, and a decision was made at the time that was the right tool for the job. And I don't know that we've done a real in-depth analysis of would it make sense for us to move all of that to SQS, or would it make sense to move all of that to Kafka? And actually, what we're doing today is we have Kafka deployed, and our backend services, as we're building newer infrastructure, they're using Kafka more and more. And it looks like we're headed towards a future where Kafka is really going to be the backbone, both for our backend banking production infrastructure and for our data infrastructure. And there's some nice things that Kafka provides that it's got durability that RabbitMQ doesn't have. You don't have to be directly subscribed to something when the events happen. Kafka will keep those around for some number of days or weeks if you have it configured that way. So the durability is nice, and then just the scalability and throughput that Kafka is able to handle it provides a lot of flexibility with what we can do with it. So Kafka can provide for a lot of use cases, whereas RabbitMQ and SQS are a bit more focused, I think, in the guarantees that they provide and the places that they are appropriate. But we're ending up using SQS a little bit in our infrastructure now too, in that we use SQS to talk to some third-party partners where they're able to put information to an SQS queue, and we're able to read that in. And so SQS is now an important part of our infrastructure too.
I see.
And it's interesting to see all of these. So we now have at least 3 message queues that we're all dealing with in our production infrastructure.
Which probably sounds a little weird because they are so similar sometimes, but at the same time they do have those major differences. Like you were saying, Kafka has major strengths that you can't really find in other queues, or at least not as eccentric in that regard. Which brings me to the next question. Why Redshift instead of just leveraging Postgres, which you already have, or something like MySQL, which a lot of people are very familiar with? What does Redshift offer that you can't find in those other engines?
Yeah, it's interesting at the scale of data we have today. It's interesting to see things like Postgres and MySQL evolve, and Postgres in some of its recent releases has been adding some more analytical functionality, some functions specifically designed to support that. And with our data scale, our warehouse is about a terabyte. We probably could get away with Postgres right now, but our data volume is going to be increasing a lot as we have customer growth and also as we're building out more pipelines to pull in more data. So I think we will be quickly outstripping what Postgres can do. So what something like Redshift can do that Postgres can't. Redshift is an analytical database. It is meant to support being able to load data in and then do analytical queries where you're looking over a large perhaps all of the records in a table rather than doing something transactional where you're putting in a record at a time, reading out a record at a time, looking at information for one particular user. With something like Redshift, you're generally doing a query where you're looking over all users to generate some aggregate of looking at what's the average transaction frequency for customers, something like that. And architecturally, what makes Redshift different from something like Postgres is, first of all, that it's a columnar data store rather than storing data by rows, and it's distributed. So the columnar data store, like Postgres, every time you insert a record, it's storing all of the various fields for that row together. And so it's easy to go in and pull out a particular row. All of that information comes out together. With Redshift, though, often you only care about one column in this table that has hundreds of columns. And what Redshift does is that you tend to load data in big batches, and it's able to take the data type that's in that one particular column, compress that information together so it's able to store it more efficiently and retrieve it more efficiently for these large queries where you need to get large blocks of data. And often there are a bunch of columns that you don't care about, so Redshift can avoid reading all of that data for those columns that aren't included in your query. So having that columnar focus optimizes it for analytical type queries, and then the distributed nature means that you can scale a Redshift cluster up to be much larger than what you could get from a single Postgres database. So as we're looking for our data load increasing, it's not going to be a problem to move up to 10 terabytes and well beyond that as we have that data that we need to analyze.
Now, Redshift is still SQL based, so you can still come from a background of MySQL or Postgres and still have the ability to quickly and accurately pull data that way, right? Are there any cons to that, or is it just beneficial?
Sure. It is beneficial in that it's an interface that's familiar to a lot of people, and particularly our analysts that are on our data team. They spend most of their day writing SQL queries and using that as the basis of what they do. So it's nice to have people be able to come in with SQL and knowledge and be able to apply that directly to Redshift. But it's also kind of this false friend in some ways of if you are used to writing complex joins between a lot of different tables in something like Postgres, it can be very hard to get that to perform on Redshift unless you're understanding how is your data distributed to the various nodes of your cluster. And if you write naive joins that don't take into account what keys are we using to distribute information to various places, what Redshift ends up having to do is broadcast entire tables across to different nodes of the cluster, and you can end up with queries that just have no hope of ever actually completing because there's so much information that needs to move around.
You can deploy an SSD cloud server in 55 seconds with your choice of operating system, your application, and any other software you need, all for free for the first month on DigitalOcean by going to scullycode.com/DigitalOcean. They offer one of the easiest and fastest ways to get started with cloud computing. After setting up your first droplet or droplets, You are guided through each step of the way, and you have access to thorough documentation and a vibrant community. So it's very easy to get started and to make sure that you focus on what matters most, you learning and you deploying. If your initial project needs to scale, that's also really easy. Prices are well laid out so you know exactly what you're going to pay, and you get access to free premier support from DigitalOcean's customer success team. Get your discount now and try it out at scallycode.com/DigitalOcean. Can you actually talk a little bit more about the distributive nature of Redshift and how it's able to distribute that data and how you know how it's distributing it so you can query more efficiently?
Yeah, I think when you build a Redshift schema, what you'll notice is that it looks very much like creating a table in Postgres, and Redshift was actually forked from Postgres 8.2, I think. So it's very similar to Postgres in that sense, but you'll notice that it has two key concepts built into the table schema that don't exist in Postgres. So you define sort keys and distribution keys for all of your tables. So when you create a table, you pick some column that's going to be the distribution key. In our case, we often use the user ID as that distribution key. And what that means is that as a batch of records comes in and you're loading that into Redshift, it's going to look at what's the value of that column for every record that's coming in, and it'll choose which node it's going to based on some hash of that value. So a specific user ID, if that's what you've chosen as your distribution key, records associated with that user ID are always going to go to the same node within the cluster. Once you have that, if you have two tables that are both distributed on user ID, that means when you join those two tables, those user IDs are already co-located, and it's easy to do that join on user ID for Redshift. Whereas if you want to join on any other key of the table, it's very unlikely that those are going to be co-located, and Redshift's going to have to do a bunch of piping data around to get that to happen. So that's been a somewhat when your table structure matches the queries that you need to do, Redshift can be amazingly efficient, and we've had some great performance out of it. But when you need to do a query that doesn't match the structure of your tables, it can be difficult to impossible to make that happen.
Is it really a trial and error when you're just getting started with Redshift if you don't have a lot of experience? Or is it really understanding how that distributive nature works and then customizing the queries around that and then just trying and seeing which queries take a while and which queries need to be changed? Is that how you approached it?
Yeah, I mean, in our case, certainly there has been a lot of trial and error. On some level, the documentation, tells you certain things about what you need to pay attention to. And it can be hard to tell when you're new, which of those are truly fundamentally important and which of those are not. So there's been some trial and error for us to convince ourselves that yes, okay, yeah, these distribution keys are pretty important. You really need to pay attention to that. But I also think that going in, we didn't know what queries were going to be important. So it wasn't obvious going in what made sense to have for the distribution sort keys of various tables. And and as we did analysis, as we learned what things were important, that helped us figure out what we have done for the distribution keys. And we ended up changing the structure, migrating to new structure for a lot of tables. So we've been able to improve performance a lot that way. And we've also done we have an ETL solution that we do within Redshift, where nightly we have a bunch of SQL jobs where we create new tables based on the kind of the source tables that have data flowing into them. And in some cases, we're just taking the exact structure of a table and just changing it to have a different distribution key so that it's optimized for some other join that we need to make with another table. So we've gotten some mileage out of that, some flexibility by duplicating some of the data, but distributing it or sorting it in a way that's going to make it efficient for analysis. And that ETL kind of process has been nice in that we can change those definitions very easily, recreate them every night, and we aren't kind of locked in to that structure the way that we are with the source tables that we're loading data into.
Now, Redshift is actually an Amazon managed service, so are you able to easily plug it into CloudWatch and see some of those performance metrics or bottlenecks that you can quickly try to change, or are you using other tools? How does that work?
Yeah, so CloudWatch does provide a suite of metrics for Redshift. A lot of them related to kind of the machine level metrics of what's the network throughput, what's the disk usage, those sorts of things. Um, we do a lot of metrics visualization through Grafana, and we have a structure of we have Graphite and statsd in our architecture, and our services are all sending metrics that we visualize in Grafana by sending them through Graphite or statsd. So at the time that we started using Redshift, there wasn't a good way for Grafana to visualize CloudWatch metrics. So we ended up building a service specifically to pull in those CloudWatch metrics, republish them to Graphite so we could see them in Grafana. But also there's a lot of stuff that's not important information about Redshift performance that's not published as CloudWatch metrics. There's a lot of information in Redshift's system tables that's important to understand. Query queues, are things getting backed up? Is there contention on commits? That sort of thing. So our service that we have that does this monitoring, it talks to CloudWatch and it does queries directly to Redshift to pull information out of those system tables and publish it. So we have a dashboard in Grafana that's able to look at all of that information and give us a nice snapshot of how are things performing now? How does that compare with previous hours or days?
I see, and I assume that you can see those system tables in the Amazon dashboard as well, or you can use the API to pull that information and feed it into Grafana or whatever else you're using like that, right?
So Amazon actually, so within the console, you can see those CloudWatch metrics, for free. They, have visualization for those. The information that's in the system tables isn't visualized in the console, so you need to do queries to Redshift in order to see that information. But Amazon also provides in their AWS Labs, GitHub account, they have kind of a whole suite of tools that give a lot of those important administrative queries and provides a framework for you to be able to run those on a regular basis. Mm-hmm. And so there's some amount of, if you want to have that regularly watched and converted into metrics, there's some work you need to do on your own. But Amazon has been building up that suite of tools so that what are the queries that are interesting and they get important information about performance.
I see. And are you using the same monitoring tools to monitor things like RabbitMQ and Postgres and all those other services in your infrastructure?
Yeah, all of those different services, we have hooked up to either Graphite or statsd. So all of that's flowing to the same place, and we have dashboards to monitor a lot of that.
So that's nice. You're able to easily plug it in without having to use all these different services for different parts of your infrastructure and all that. That's nice.
Indeed, and this is another case where tooling is continually evolving, and Grafana now offers direct CloudWatch access. So that's a whole suite of stuff that we can get directly into Grafana now without having to do this roundabout thing of republishing to Graphite. So things would certainly look a little bit different if we were rebuilding it today, but what we have has been pretty reliable.
Nice. You also built a tool in Scala that collects and publishes Redshift performance metrics. Can you tell us a little bit more about that?
Yeah. So as I was discussing in the previous question about our whole ecosystem of Grafana and what exists. Yeah. So a lot of our infrastructure has been let's build a service to do a particular thing. It's kind of what our operations team is familiar with. And in particular, like we do a lot of Scala, so we have a well-defined workflow for how do you create a service in Scala. We use the Drop Wizard framework, and in our case, for data, very few of our services actually provide an HTTP connection. So we're kind of using Drop Wizard, which is this web framework, but we're kind of disabling the HTTP part of it and just using it as a nice framework for scheduling tasks and and defining, what work do you want to do? So that's the shape that this took because we're familiar with it operationally. It was, the thing that we know how to build. So we built a Scala Drop Wizard service, and it's pretty simple. It's kind of organized into a couple of collectors for the different data sources. One is CloudWatch. One is queries to Redshift system tables. and it just runs each of those periodically, a lot of them once a minute. So every minute it pulls CloudWatch, pulls down the new values for the metrics, publishes those to Graphite, and every minute it runs these queries, talks to Redshift, gets information back about what's the commit queue look like, what how many user queries are sitting waiting to be executed, all those sorts of stats, and then we have a dashboard, and that is when when somebody is noticing that performance on Redshift is slow or whatever, there'll be on our Slack channel somebody saying, hey, Redshift seems weird, and then the first thing we do is we go right to that Grafana dashboard, and a lot of times it'll be obvious, like, yeah, there are a bunch of user queries that are sitting around. Why is that? And then you see that there's this huge spike in disk usage, which is a clear indication that somebody's written a query that's spilling to disk, and it's probably never going to complete. And we end up killing that query in order to free up the disk space and get other people onto the queue.
I'm curious, why Scala? And the reason I'm asking this is because with Java 8, we've seen companies like LinkedIn where last I checked, they actually had moved to Scala and then again moved back to Java, I guess because they didn't see those performance benefits, or even finding the talent was difficult. Why are you guys still sticking to Scala, or why are you using Scala?
Yeah, it's going to be interesting to see how that evolves. I think we're pretty dedicated to the JVM at this point. We have a lot of people that have a lot of experience, both in Java and Scala. We have people that have experience doing performance tuning on the JVM. So I think it's unlikely that we'll move away from that suite of languages in the JVM as a base, at least anytime soon. But it is interesting to see the benefits that Java 8 has, and it does provide many of the things that made Scala particularly interesting compared to Java. We are starting to see some of our backend services are starting to get written in Java 8. We're doing some more migrating of Scala libraries. We're trying to factor some of that out to be pure Java so that it can be used in either Java projects or Scala projects. I'm not exactly sure where that's going to go. There are some folks that think that we should do more Java 8 and kind of simplify based on that. But even with the new features in Java 8, I'm actually working on a Java 8 project right now, and it's a great learning experience to understand the things about Scala that are really nice. Some things just like case classes are this construct in Scala where you kind of give it a series of fields, and you can very easily create this immutable object that's thread safe. You can pass around, you can create copies of it with modified fields without affecting the old version of it. And it turns out to be quite involved and error prone to try to match that same sort of pattern in Java. So we have the situation where you can choose between Scala that has a lot of this stuff built in, or Java 8 where you might end up pulling in a bunch of third-party libraries that are kind of opinionated about how you do things. And have you really kind of removed dependencies by moving to Java, but using a bunch of libraries that you wouldn't have had to use if you were in straight Scala. So we have different opinions, and we're working through that.
I've only done a little bit with Scala, and from what I've done, it's been both a joy and a pain because the learning curve is a little bit steeper, I would say. And also, especially if you come from a Java background, and we've spoken about this before, where if you have a Java developer, a lot of times they'll try to write Scala in a Java fashion, in which case you actually lose a lot of the benefits from Scala. But then you'll also have a few lines of Scala, but to do the exact same thing in Java, you would need a few paragraphs of Java. So a lot of times you can really compact things up, which is also a double-edged sword because in my case, since I'm not that familiar with it, if I'm new to the code, I could stare at the code for a few hours and still not really understand exactly what it's trying to do. So I guess it does have a little bit of a steeper learning curve. I mean, how do you feel about that?
Well, it's interesting. I actually had not had experience with the JVM before coming to Simple. So I came into a culture that was writing all Scala rather than straight Java. So Scala was my introduction to the Java ecosystem, and now we're starting to write more pure Java. And so so that has been interesting to me, in that there are a lot of things that I take for granted in Scala, and it just seems crazy that you have to write all this boilerplate every time when you're writing pure Java. But yeah, we have some people in the company that come from a definite hardcore Java background and end up writing Scala that doesn't take advantage of a lot of the benefits that Scala provides. So yeah, there are things that each are uniquely suited to, and I'm expecting that we're going to end up continuing to use both of them in tandem, and there will be cases where Scala makes a lot of sense and cases where Java 8 makes a lot of sense.
If you work on Amazon Web Services and you're trying to learn better ways of accomplishing your job, or even if you're totally new to the platform and you want to get started, Linux Academy offers some of the most comprehensive AWS training that you can find. In fact, Linux Academy has excellent AWS certification pass rates, and many companies as well as thousands of professionals use our platform to train. Get started now for only $9 the first month by going to scallycode.com/Linux Academy. For the price of a Netflix subscription, you can learn from experts and make yourself more valuable, which means you can get paid more. Come join me and our team, and we'll make you an AWS Pro. Go to scallycode.com/Linux Academy. So we've been talking a lot about the back end of this data analytics engine, but at one point in time, you actually have to visualize this data, right? So maybe an engineer, an executive, or a client wants to pull data out of it and make sense of it. How do you do that?
Yeah, so that's the whole point of having this infrastructure is, at least for us, originally it was the executive leadership team wanting to, be able to make clear quantitative statements about what is the business doing, where are we headed, how are customers interacting with our product, what's their relationship with Simple, and getting quantitative answers to that. So some of that is, Redshift offers the SQL interface. Our CEO, Josh, he has a whole background as a programmer. He's done data stuff in previous careers. So there are times that, we've just given him access to Redshift. He dives into it and does his own analysis to kind of explore what data is there, which is kind of a cool thing to see. So it's nice to have some key people throughout the company have a very, analytical mindset, be able to do some of that digging on their own and answer their own questions. But to make the data more widely available, we do a bunch of visualization. Our data team, you want to talk about the data team? I'm a data engineer. I focus on that infrastructure stuff, building out Redshift and the pipelines. But half of our team is actually data analysts that are focused on analyzing data, understanding the schemas, answering business questions, and we have basically the rest of the company as our clients for the data analysts. So they spend a lot of the time pairing with individual teams, figuring out what questions they're trying to ask, helping them refine, what are those questions? How does that relate to the information we actually have? And then they do visualization of that data. So sometimes they're doing it, on a case-by-case basis, making presentations to groups. But probably the biggest form of visualization we have now is we use Periscope data to create web dashboards. So we'll have a whole page that is various panels that are each a SQL query that's talking to Redshift, pulling information back, and often visualizing that as a time series. So one thing you might take a look at is something we try to optimize for is when a customer first signs up. One of the frustrations of being a bank and providing a checking account is that we need to get the customer that their debit card in order for them to really start getting the benefit from Simple and being able to use the product, and that takes a little while to create the card and then ship it off and get it to them. So we wanna understand what's going on with that very closely. So our service that ends up talking to our card partners and ordering cards is emitting events that is being sucked into Redshift. And so we have tables that tell us, when, for a particular user, when was their card, ordered, when was it created, when was it shipped, and then, we can and then also when was it activated, so we can keep track of who hasn't activated, how long does it take people to activate their cards, is that trending upward or downward, are there things that we need to talk with partners about. So that's something that our marketing team takes very seriously. They monitor that information, and that's something that we can present in a dashboard to show in aggregate how are things going for customers, and that in terms of that initial experience and when they're getting their cards, are they engaged, are they activating their card, and are there things that we can do to get them more involved and make them more likely to activate their card when they do get it.
So you can actually see sometimes when you lose the customers, right? They've opened their account, they're receiving the card, and then maybe they never activate. So maybe you can go back and say, well, maybe they should have had that card sooner. How long did it take to ship that card? Can we minimize that? I could see that being super beneficial for sure.
We definitely keep track of that whole funnel of what are the milestones for a new customer before they become active and are really using their account. And that's a cool thing to see, where data can really power a lot of what our marketing team does in kind of optimizing that experience, making it more pleasant, keeping customers more engaged, just keeping them informed about what's going on, so that we have actually set up a whole email pipeline based on that data too, where we can let customers know, hey, your card should arrive on around this particular date. Here are some things that you can do to learn about what simple offers in the meantime, and then we can send them reminders if they haven't activated their card. Say, hey, your card should be here, and it gives us a nice chance to kind of build a relationship with that new customer too.
How do you actually take the data from Redshift and plugging into Periscope data?
Yeah, so I think Periscope data, one of the things that makes it great is that it is a really simple idea, in that it is, it's dashboards in SQL. So there's really nothing we need to do other than, signing up with Periscope and inputting some credentials for them to be able to connect to our database. And beyond that, it is doing direct queries to Redshift. It's actually a little bit more complicated in that part of Periscope data's magic is that they're running their own Redshift clusters, and they actually pull data in batches, and so they're kind of managing all of that so they can provide answers more quickly than having to hit our database every time they do some caching.
Interesting.
And some smart things. Yeah. So, but from our perspective, we don't need to know about any of that happening. It's just you provide queries as if you were hitting Redshift directly, and they handle whatever translation they need to do to get that to hit their cache.
So as a customer, all you have to do is write that SQL query, and somehow the data just appears, and it comes from your information. And but behind the scenes, they're actually doing a lot more magic. That is interesting.
Yeah.
Now, as we close up the conversation, I want to take a little bit of a broader or more general overview question types, where you've had a lot of experience. You've been doing this for a few years now. When you build real-time data analytics, how can you make sure that when an executive or an engineer or customer or marketing agent or whoever looks at the real-time data or near real-time data, how can you make sure that this data is not skewed or doesn't have noise to it that changes the way that we would maybe think of the data itself, and then that would lead us to make a bad decision? How can you really do that and categorize the data in that way?
Yeah, so I think the question you just asked, there's kind of an infrastructure piece of it of, how do we know that this data is reliable and
right.
that what we're presenting is what we think we're presenting. And that's something that we try to handle with alerting. We have these queries that are running against Redshift. Another piece that I didn't mention before about our monitoring service is that we do counts of the rows in various tables, keep track of how that's changing. If there's a table that we generally expect, there should be new records coming in every hour, and 6 hours go by and there's been no update in the number of records. We get alerts that show up in our Slack channel of like, hey, there might be something going on with that. So we try to keep on top of some data issues that way, and be able to intervene before somebody's doing analysis and getting results that look weird, or looking at a dashboard and seeing that there's been some fall off. So we try to be proactive about that. We're certainly not perfect at it, and there are times where users have to come to us and be like, hey, does this seem right to you? And then we end up having to figure out some pipeline issue. I think the bigger problem that our analysts see is that any analysis, there's a lot of context that's needed. Like you can present some graph that shows some nice lines, and those lines, can be entirely true, and the infrastructure can be working perfectly. But I mean, they're true only in a sense of if you understand the whole context of where do those numbers come from, and then you have the right mental model to interpret what do those mean for making decisions about what we're going to do, or where does it look like we're headed. So that's kind of, I guess, the fundamental problem of being a data analyst. Really, what you want to do is tell stories with data. You want to help people reach good conclusions from these quantities that we're able to pull out of our infrastructure. And that can be hard. Even something that our analysts talk about a lot is averages can be really misleading. A lot of what we do is aggregating to see what's the average customer's experience with some given part of the application. But what does that mean? There's the traditional concept of the mean, where you kind of add up what is it for everybody, and then you divide by the total number of of people, and you get some number out of that. But often that's skewed from what the the mean is. If you take that whole list of people and you pick the one that's right in the middle, that might be a very different number from what the mean is, and it can be a more telling number of what's the average customer's experience. But you might be interested in percentiles of 99th percentile of if things are bad for 1% of customers, that can be a really bad thing too. So providing that context to understand, okay, we're providing you with this average, but what does that really mean? What does it represent? Why do we think it's an important number or not? Especially when you're doing dashboards, it can be difficult to make sure that the people looking at have all of the context that they need. And a lot of times it's a whole problem of defining even what do you mean by the terms that you're using. So if you have some title on a panel that says this is looking at active customers, what even is an active customer? Do we have a definition for that? Yeah, we do have a definition for that, but sometimes there's nuance to that definition that, depending on if you're marketing or if you're our risk team, looking at fraud, who do you want to consider to be an active customer? If you're the finance department, you really care about those fraudulent customers because they end up costing us a lot of money. So we want to include that activity in what we present to our finance team, but we might not want to include that in information that we present to our marketing team because they're interested in what's the experience like for real customers that are signing up and going to be engaged with the product. So understanding those different needs of different teams has meant that we end up creating dashboards a lot of times that are tailored to a specific audience, where we have a better sense of what is the context for these people going into it, what is the information they actually want, and we have to kind of present those numbers in a way that makes sense to the audience that's going to be reading it.
Yeah, this is a really interesting topic and loaded topic as well. And a lot of what you just said could also be applied to systems themselves, where if you're measuring performance of a database, for example, if you're just looking at the averages or that kind of information, what if you miss the big spikes that would tell you a story, that would tell you that there's something wrong, but because you're looking at the average itself, you're not seeing those spikes and you think everything's okay. So this could, I feel like this could really be applied to all kinds of different things. And also, the reason I was asking you this question, as we've talked about in the past, is a lot of times you'll see these either political or financial or whatever graphs that are attempting to represent something, and they look very compelling, right? They're telling you a very compelling story, but maybe it's just because of the way the data is actually represented. If you represent it in a different way, it would tell you a different story, and it would compel you towards a different side of things. So what if you have a big decision you need to make from this kind of data, and it is skewing the data in a position, it's not neutral data, so to speak, and you make the wrong decision off of it. So I think, we could be talking about this for days, and we probably need to bring on a data analyst to really dig through this. But this is definitely a very interesting topic.
Yeah, I mean, it's interesting. I mean, particularly as you talk about politics, I feel like there are like two different layers there of, if you get to a point of like you want to support a particular opinion, there's a lot that you can do to, to choose how you're going to analyze it to come up with a result that you want to show. But even if your intentions are pure and you don't have an agenda, it can still be really difficult to tell a story that gets you an answer that's really useful for making that prediction of what's going to happen or making a decision about what do we need to do. Yeah.
So long story short, be careful what you believe
Yes.
on social media. Be careful what you share back and retweet, because even if it looks right, make sure you're looking at how they even came up with those graphs.
Absolutely.
One more question as we close up, Jeff. I wanted to ask you this because Simple's data analytics engine has had a few years to mature now. So it's a well-established platform. You've had a lot of engineers work on it. But if you were to go to a startup that needs this kind of data analytics, how would you recommend they get started without wasting too much time or too many resources?
Yeah. So on one side, that is changing every day as is in terms of what tooling is available. Things have certainly gotten a lot easier in a year and a half that we've been doing this. So starting today, there are different things available than there were a year and a half ago. I also want to emphasize that it took we had a team of 4 engineers working on this from the gate. We now have 6 engineers a year and a half later, but it took 4 of us a good 6 months to build an initial version of this, to have useful data in Redshift that people were using and being able to come up with the answers that they need from. And that can be a huge investment for a startup. And I think in a lot of cases, that's out of reach, kind of building your own architecture for that. So there are there are lots of companies out of there that are trying to make that easier. Amazon itself is making it easier. So it's a lot easier today to use Kinesis Firehose, for example, and just put messages onto onto a Kinesis stream, and Amazon handles a lot of those details of getting it to Redshift for you. So definitely use those tools that exist. There are, and then there are also lots of companies, building on top of what Amazon and other cloud providers are putting together to try to really manage that whole pipeline for you. And if you're a small startup, it can be well worth the money to go with a third-party solution like that, rather than trying to build the infrastructure yourself. But also keep in mind that as you grow, you're going to want to take on more of that responsibility, and having some sense of choose a solution where you own the data and can transition to something else where you have more control over what you're doing.
Jeff, thank you so much for doing this episode. I learned a lot from it and really enjoyed researching and speaking with you. So thanks a lot for doing this. If people want to reach out to you or if they have any questions, how do you recommend they do that?
Yeah, I'm klukas@simple.com on email, and I'm on Twitter at Jeff Klukas. So I'd be happy to talk more about any of this.
Awesome, thank you. And also, I should have mentioned this earlier, but Simple has an engineering blog where this I really got inspired for this interview. Jeff wrote this lengthy, or detailed, I should say, article about this entire data analytics engine, and it has pictures, graphs, which could really help you understand a little bit more of what we talked about. So sorry, I should have mentioned this earlier, but be sure to check that out. What's the URL for the engineering blog?
It is simple.com/engineering, I believe. And okay. The article is called Building Analytics at Simple.
Well, if that doesn't work, then you can Google it. It's really easy to find. But thank you all for tuning in. Please leave a comment and thank Jeff for his time and for his expertise. Thank you all for tuning in.